Hello, my name is Tom Dienhart and I'm currently a first-year PhD student at Marquette University in the Biomedical Engineering Department. I am a member of the Translational, Experimental, and Computational Cardiovascular Research Lab under the guidance of Dr. John Ladisa. My collaborators are Dr. Deepak Sharma, Dr. Robert Prost, and Dr. Aliston Marsden. My research involves studying the fluid environment within a dialysis access. These accesses is where the needles are placed for a dialysis patient when they go in for dialysis and is their lifeline. Unfortunately, nearly half of these accesses that are created fail within 4 years. There are three main types of vascular access. The first type is the fistula, where a surgeon directly connects an artery to a vein, creating a very high pressure gradient to drive a lot of flow through it that is required for dialysis. The next type is a graft, where a graft material is placed between an artery and a vein for the same pressure gradient. Last, there's the catheter, which is the least favorable because it has a high risk of infection. I'm currently looking at the effect a stent has on fluid flow when it's placed within one of these accesses. These stents are typically used to reopen an access that is stenosed due to neointimal hyperplasia, which is a fancy term for saying that the inside of the vessel has grown a lot to cause this stenosis. It has been shown in previous studies that these stenoses are caused by low wall shear stress and is a measure of the viscous force of the flowing blood acting along the wall of the vessel. I'm using computational fluid dynamics and an artificial model of a fistula, which is the most popular type, which I created from normal data and created into a fistula as seen on the screen currently. After I did this, I created a mesh with an implanted stent to study the fluid flow and solve for the Navier-Stokes equations to be able to calculate wall shear stress. Lastly, you can see my results here of blue being low wall shear stresses and red being high wall shear stresses. I have found that by placing a stent, the amount of low wall shear stress increases within the stented region and downstream of the stent, increasing the risk of restenosis. Thank you, and please check out my abstract and slideshow below for more information.